Welcome, everyone. I know many of you, but I'm Brett Thielen, the Science Director for the Harris Center for Conservation Education. It's my pleasure now to introduce Carol Foss. Many of you may know her. Carol is the Senior Advisor for Science and Policy at New Hampshire Audubon, and she's a member of the steering committee for the New England Motus Project. And a few years ago, Carol convened a gathering of ornithologists and conservation biologists and other folks who are interested in migration at New Hampshire Audubon. Eric Masterson, one of my colleagues at the Harris Center, who many of you may know, he has spent more time thinking like a hawk than anyone else I know. And he and I were both in attendance at this gathering. And the purpose of this gathering was to introduce to us a new technology that was helping to learn about the migration of small winged creatures, shorebirds, songbirds, saw-whet owls, bats, even dragonflies and butterflies. And we left that meeting with our jaws on the ground because we were just blown away by the power and the potential of this new technology. And Carol will tell us more about how it works, but just to give you a really quick sense, it's a little bit like an easy pass for critters in that there's two pieces. There are tags, like the tags you might have in your car, and then there are detectors of the tags, kind of like at a toll booth. And so there's both of those pieces come together. And the Harris Center is really excited because we are going to be hosting a receiving station, the toll booth as it were, on conserved land in Stoddard. And we are going to be the first receiving station, to my knowledge, installed as part of the New England Motus project that Carol is going to be sharing with us tonight. And we're just really excited. It'll probably, if all goes well, by next Friday, it may be in place on our land, and probably not, I'm imagining, detecting passing critters until next spring would be my guess, just because migration is starting to wind down now. But this project, as many of you know, we've just kind of finished celebrating our 50th anniversary year. And part of that year was fundraising for a special 50th anniversary fund, which among other things was designed to support innovative projects for the next half century. And so our involvement in the Motus project is made possible through our 50th anniversary fund. And it's one of the very first projects to be funded as part of that effort. And I know that there are donors among us tonight. So I want to thank all of you for supporting the 50th fund and projects like this. And I hope that when you leave tonight's program, you'll feel a sense of pride and excitement about what you're helping to make possible in terms of conservation research, because this is really, really jaw-dropping stuff. So with that, I'm going to turn it over to Carol and remind you that if you have questions, please feel free to put them in the chat, either to me directly or to everyone to see, and we will lob them at Carol when the time is appropriate. So with that, I'm going to turn it over to our expert tonight and thank her for coming. So it's all yours,
well,
Carol.
Thank you folks for having me, and thank you to the Harris Center and all the donors in the room for making this first station possible. It was very exciting to us when Eric approached me months ago and said that the Harris Center would really like to host a station. So I'm going to start with kind of an introduction to migration research and then get into the nuts and bolts of Motus. So bird migration has fascinated humanity for centuries, but the ancients had no idea where birds were coming from or going to. They just got accustomed to these huge flocks of birds passing overhead at predictable times of year. Eventually, folks started putting bans on birds, which was great for waterfowl because waterfowl are hunted. So when banded waterfowl were shot, the bans could be removed and get returned to the agency that was issuing them. But for songbirds, the chances of recovering a banded bird were pretty darn small. And regular bands are pretty useless if you're trying to study birds, like how many chickadees are coming to your feeder. Trying to identify individual chickadees from one of these bands, even with really good binoculars, is pretty tough. So eventually, biologists started using color bands so that they could identify individuals in the field. And that worked pretty well. You can see the scrub jay has 2 different color bands on each leg. So that was a good innovation, but you've still got to be pretty close to the individual to identify it. So then the shorebird people, because shorebirds have such skinny little legs, you really couldn't see much on color band. They started using leg flags, which have this tab that you can put an alphanumeric on. So that was great for the shorebird people. And then folks working with large birds that spend a lot of time in the air invented patagial tags or wing tags that are attached to the wing and can be seen either from above or below. So that worked great for that category of birds. Then this is the one kind of tag that I have never actually seen, but waterfowl biologists invented these nasal saddles, which apparently worked for them. Large waterfowl folks studying the very long-necked waterfowl started using neck collars, which have very large alphanumerics and can be read pretty easily with binoculars, whether the bird is on the ground or in the air. So that was the status of things for quite a while. And then cell phone transmitters came into being about 15 to 20 years ago. And that kind of took the field work out of biologists, or particularly graduate students, because instead of running around in the field tracking down your subject animals, you just sat at your desk, and when your tagged individuals came within range of a cell phone tower, you would get this big dump of data to your cell phone. So this whole technology has just developed very rapidly over the last 15 to 20 years. Satellite transmitters are also available, but both for the cell phone transmitters and the satellite transmitters, you need a pretty large bird in order to be able to carry the battery pack that can transmit the signal. So this was all revolutionizing migration studies for larger birds, but songbird folks were still stuck with regular VHF transmitters, which are great if you're in a local area, like on the breeding grounds, because you're running around with a receiver and an antenna. But once birds start moving long distances, even with an airplane, it's just about impossible to track them on migration. And we have done some tracking with an airplane, but only to do grids to look for missing birds during the breeding season. So then maybe 10 years ago, light level geolocators were invented, and these are magic. you have this little transmitter with this little light sensitive tube sticking off it. And what these do is the light sensitive tube documents when it gets light in the morning and when it gets dark at night. So using various algorithms, you can figure out within maybe 100 miles where the bird is by figuring out when sunset and sunrise are happening and when the middle of the day is. So as you can see from these maps, you get kind of a probability. The good thing about these is that they take data every day. The less good thing is that it's not very precise, but if you're tracking a bird from North America to South America and you want to know if it's wintering in Colombia or Venezuela or Bolivia, it'll get you there. The rub is that in order to find that out, you've got to recapture the bird, remove the device, download the data, and subject it to these complicated algorithms. So you can put out a lot of these devices and only get a few back. But nonetheless, it was a huge step forward for studying songbird migration. So then the next innovation was pinpoint or geolocators or GPS tags. And the step up from these is that they give you very precise points. The downside is that they will only hold a certain number of them. So before attaching them to a bird, you program them to turn on at a certain time on certain days. Some of them now will take like 50 different coordinates. So at the prescribed days and times, these turn on and look for satellites just like your handheld GPS would, and hopefully enough satellites are in the right positions so that the device can get coordinates. If it turns on and the bird is under a heavy canopy of trees, you may be out of luck. But at least you get very precise locations of where your birds were at those specific times. With these, you also have to recapture the bird and remove the device and download the data, but you don't have to do any processing. You download the data and boom, you've got your points.
Carol, there's a few questions about, I think this might be a good time to ask them about
Sure.
the process of affixing. I mean, the bands look fairly obvious, but some of these other ones that are on their backs, how does that work? Is it a backpack?
Yeah,
or...
let me go to the next. That's a really timely question because this shows a backpack. So we use what's called a leg loop harness, and you have two loops of, host has spotlighted, okay. There are two loops and one goes around each leg. So it goes kind of under the wing and around the leg. And then the device kind of sits on the back. So we had the opportunity in 2018 to deploy several of these light level geolocators on rusty blackbirds, complements of the Smithsonian Migratory Bird Center. And we were fortunate enough in 2019 19 to be able to recapture one of those birds and see where it went. And one of the fascinating things we learned from that bird is that after the breeding season, this bird, which had nested in Atkinson and Gilmanton Academy Grant, which is an unincorporated place north of Errol, this bird went north to Pittsburgh and was there by early August and spent until early October roaming around Pittsburgh, which was a great revelation to us. And we've since learned that a number of rusty blackbirds, not all, delay their fall migration and go somewhere not too far from their breeding grounds to molt during September and October. So this is something that we want to learn a lot more about in the coming years, but it's fairly new information. So it went north and then eventually it headed south, which is the red line. And we have several points where it stopped along the way. And it spent the entire winter within an area of a few acres in North Carolina, which was pretty interesting. And then it wound its way back north over a somewhat different route. It stopped, I visited most of the places in Pittsburgh where it stopped and the places in Massachusetts where it stopped. And on the way, in one direction, it stopped in Campton, and in the other direction, it stopped in Lyman, New Hampshire. And I was expecting the route to kind of follow river valleys, but both the Lyman and Campton points were way up on the top of ridges where there were little beaver ponds. It was pretty interesting. So that's where we were until about 5 years ago. We could learn all this great stuff, but we had to recapture the bird and remove the device. So you could put out a lot of devices and only get a few back. So it was pretty expensive. And then came Motus. And Motus is a collaborative research network to track wildlife movement. It involves automated radio telemetry. All of the radio tags are on one frequency, and the receiving stations operate continuously with up to 8 directional antennas. And the tags are designed to be detectable about 15 kilometers out from a receiving station. And the best part is you don't have to recapture the animals. They'll get detected by any station that they fly within about 15 kilometers of. They come in a number of different sizes. They're being used on bats, on small songbirds, and even on monarch butterflies and the large green dragonflies that migrate. The receiving stations need power. They can be set up in a remote area like yours is going to be and powered with solar panels and batteries. And we use kind of a big waterproof container at the bottom of the tower to hold the batteries and the brains of the outfit, which are in a box about the size of a small suitcase. This whole network was established by Bird Studies Canada, which is now Birds Canada, I believe. And it was initially set up to study shorebird migration. So the initial distribution of Motus receiving stations was along the Atlantic coast and the shores of the Great Lakes primarily, although you'll see a few along the northern coast of South America. So folks did research on semipalmated and white-ruffed sandpipers, on dunlins, piping plovers, and especially on red knots, which is a globally endangered species. And one of the things that was discovered by putting these tags on red knots, people knew that there was a large migration staging area in Delaware Bay. That was well documented. And they knew that they nested in boreal Canada, but how they were getting from point A to point B, no one really knew. Well, Motus documented lots of flight paths going right over Pennsylvania, and birds then being picked up in Ontario. So not having much of a shoreline, Pennsylvania had no idea that red knots had any kind of presence in the state. But because Pennsylvania has a lot of wind energy development on all those ridges, they were able to put the red knot on their state list of threatened and endangered species, and then use this data to help inform areas where wind farms should be avoided to prevent collisions with red knots. So that's kind of one example of a conservation application of this technology. So then the salt marsh sparrow folks thought, well, we can put nanotags on salt marsh sparrows. There's this great coastal network of receiving stations, and learn what is going on with their movements. So that was another of the early projects along the North Atlantic coast using this technology. So then, probably, time is flying, 4 or 5 years ago now, excuse me, a group of forward-thinking folks in Pennsylvania decided, well, if we could get a network of receiving stations in the Northeast, in inland areas, we can learn a lot about the migration of forest songbirds. So here's the great black hole of the Northeast. So they started a project in Pennsylvania to build a fence line across the state with receiving stations approximately 25 to 30 kilometers apart, so that any bird flying across the state, or flying north-south through the state, would hopefully get picked up by one or more of these receiving stations. So the first meeting that Brett alluded to in her introduction resulted in the group, which included folks from the Mid-Atlantic and folks from New England. The group decided that they would the Mid-Atlantic states would put in, or what's called a competitive state wildlife grant, or a CSWIG grant, which is a grant program with the U.S. Fish and Wildlife Service that involves multiple states collaborating together on some landscape scale project. So the idea was that they would put in this big proposal in I think they were due in July of 2017, maybe. I guess it would have been 2018 because it came through for 2019. So, and then if their grant was successful, we would follow it the next year with kind of a partner grant for the New England states. So their grant called for installing, I think, 46 receiving stations in Pennsylvania, Maryland, New Jersey, Delaware, and New York. And it also involved field projects on 8 species of greatest conservation need, which is kind of it's a broader category than threatened and endangered, but it's species that have been identified by states in their wildlife action plans. So the sort of vision for that project was to build these fences across the region. So the red, I think the red ones were existing at the time of the proposal, and the proposal was to add all these blue sites in Maryland, Pennsylvania, New Jersey, and New York. So lo and behold, that proposal was funded, and we were fortunate to be one of the field projects that was utilizing, or was to utilize, this data or these receiving stations. So again, we put nanotags on rusty blackbirds this time, and you can see the antenna sticking out there. We tagged 9 adults in 2019. 8 of them were detected on fall migration. 2 were also detected on spring migration. And this year, our field biologist located 4 of them on the breeding grounds, including 1 that was never detected on migration. So that bird took some unique route that did not go near any receiving stations. So 1 bird was detected at as many as 15 stations and on 23 different days. So this is kind of hard to see, but this gives you a sense of kind of a tight ribbon of where their paths went south. And we had 2 birds go as far south as South Carolina, and 1 go all the way to Georgia. Unfortunately, there is no inland network in the Southeast at this point either, because I would love to have inland stations so that we could get a sense of where some of these birds are wintering. But just knowing how far south they're going is more than we knew before. So just to give you a sense of the bird that was detected the most times, it nested in Grafton, Maine, and during October, again, it spent that August, September, October period somewhere up north during the molt. and then headed south. It was picked up by a Connecticut Audubon receiving station. So they were very excited because their station hadn't been up for very long. It was one of the first birds that they detected. Then spent some time going through the Chesapeake Bay area, and ultimately was picked up on the coast of South Carolina. Probably spent the winter somewhere inland, maybe in Georgia, maybe in South Carolina. And then in the spring, in March, headed back out to the coast and then up through the Chesapeake, and was last detected in Connecticut. So also as part of the Mid-Atlantic project, the bird banding lab has been insisting that if you are putting nanotags on birds, you have to install a local receiving station. So we did in our rusty blackbird study area in northern New Hampshire. And you can see this is, I think you may have a slightly different mast on yours, but this is what your solar panel will look like. This is what your box at the bottom will probably look like. And because we were targeting our rusty blackbird nest sites, our location was kind of on the side of a hill, and that's why there's no detection to the southwest. So these loops show the approximate detection area of the antennas on that receiving station. And for a migration station such as yours, there will be 8 antennas, and they will give 360-degree coverage. So I just want to share a few of the cool detections we have had at that receiving station. We detected a red knot last August, and you can go on the Motus website and figure out where else the birds that are detected by your station have been detected. So that's how I put this together. So in May, it was detected between Beaufort and Charleston, South Carolina, and at a couple of different stations. And then headed north, was picked up in Pennsylvania, and then in New York, and then went somewhere north into Canada for the breeding season. And then last summer, on its migration south, it was detected by our station in Dixville on the 1st of August. And by the 4th of August, it was back being detected by one of the stations where it had started out from in the spring. So that was a pretty neat story. Excuse me. Another red knot was tagged during migration stopover at Cape May, New Jersey, and it stayed there after being tagged for about 10 days. And then on June 1st, it was picked up by 4 successive stations in eastern Pennsylvania. Boom, boom, boom. So if you were interested in studying how fast these birds can move, you could look at the time period it passed each of those Pennsylvania stations and the distance between them and get a sense of how fast it was moving. And then a day later, it was picked up on the west shore of James Bay, which is pretty impressive distance to travel overnight, I would say. And presumably it nested somewhere north of there. We don't know where, because the next detection was at our site in Dixville in August on its way back south. And then another cool one was a Semipalmated Sandpiper that was tagged in June near Churchill, Manitoba. Our station picked it up on the 27th of July, and it was picked up the following day at a station on the coast of Maine. So that was pretty cool. This year, we deactivated our station for the winter because they had had 13 feet of snow there the previous winter. And I was concerned, A, that the antennas might accumulate some ice that might then fall down and crack the solar panel. So we padded and covered the solar panel with a tarp. And then if the solar panel had been covered with snow for a long period of time, the battery would have gotten drained. So I brought the battery home and just put it on a trickle charge for the winter. So because of COVID, not that many people put out tags this year, but they were putting out tags in South America. So this Semipalmated Sandpiper was tagged on its wintering grounds in Brazil in February and stayed there until the 9th of May. It was then picked up by a station in Delaware on the 22nd, probably did some staging somewhere down there, and then flew over Dixville on the 3rd of June. So that's all been very exciting. So in the meantime, we wrote this big grant proposal last summer, and as of July 1st of this year, it was approved for a period of 3 years. And the federal grant is for close to $1 million, and then we need to provide a 26% match for those federal dollars. As I mentioned before, these are collaborative projects involving multiple states. So Fish and Game is the lead agency, and then Maine, Massachusetts, and Pennsylvania's wildlife agencies are considered partner agencies, which basically means that they are managing at least 10% of the total budget. So in addition to New Hampshire Audubon, the Carnegie Museum of Natural History, Maine, Massachusetts Audubons, and the Willistown Conservation Trust are the partnering organizations in this effort. And this is very conceptual, and we've refined it a bit at this point. But this shows you the concept of putting fence lines across New England. And there are already some stations in New York, so we're trying to have our fence lines kind of connect up with stations in New York. And your station is right on the southern New Hampshire line, which is great. Excuse me. So your station will look a lot like this. So the Fish and Wildlife Service advised us that we did not have to be quite as ambitious as they were in the Mid-Atlantic, and we did not need to have 8 field projects like they did as part of the overall grant. we have three. One is being conducted by the Carnegie Institute, and they will be looking at different configurations of antennas and receivers to kind of see what is the most effective and gets the best detection distances. There's also another new tag that's been invented called a life tag, and they are solar powered. So they're designed to stay on the bird for its lifetime and be able to be detected going back and forth on multiple migrations. Massachusetts Audubon and the Massachusetts Division of Wildlife will be doing a project on kestrels, looking at their movements in the landscape, both during the breeding season and during migration. And New Hampshire Audubon is going to be doing a project with monarch butterflies. There's a newly developed transmitter that weighs only 0.15 of a gram. And I think the previously smallest one was either 0.2 of a gram or 1/4 of a gram. I can't remember which. And the only project that's been done with monarchs to date was done with that heavier, heavier transmitter. So one of the things we will be doing is affixing temporarily a transmitter to a weather balloon and testing how far we can detect the transmitter when a monarch is on the ground, say on milkweed, at treetop level, and then at various elevations above the trees, and kind of get a ground truthing on detection distances for those new transmitters. And we'll be working both at the coast and in the Merrimack Valley. So here is New England. You can see that there are some existing stations, primarily along the coast. And currently active stations in New Hampshire are our station in Dixville. There are several up and running at Hubbard Brook. Antioch has activated the Langdon station. I'm not sure. I think Wintastaquit is operating, but nobody has checked it recently, although there's some Antioch folks that were hoping to be able to get out there this fall. The other innovation since a couple years ago is that now there are receivers that can communicate directly with cell towers. So we can install receivers that will automatically upload data to the Motus website rather than someone having to go out there every 3 or 4 months and switch out the SD card to download the data. So this technology is evolving all the time. So this is another graphic of our proposed fence lines. While the lines are straight, the fences ultimately will not be, because you need to find a good high location that has good sky view, 360 degrees, hopefully. You need to have access up there so that you're not schlepping all this equipment up a mountain on people's backs. And you need to have a willing landowner. So while these lines are kind of targets, We'll be going through a GIS exercise this winter looking for potential sites along these lines, and generally within maybe 50 miles of the line, and then contacting landowners to see who is willing. So all of that, needless to say, is a lot of work and time consuming. So the fact that the Harris Center was on a line and came to us was huge. Globally, there are more than 500 receiving stations on 5 continents now. As you can see, things are increasing in South America, kind of taking off in Europe. Asia and Africa, not so much. There are, and this is not the latest, but there are well over 200 research projects with more than 300 collaborators. More than 17,000 tags have been deployed on 4 insect species, 18 bat species, and 164 bird species. And in comparison to the number of returns you get on bird bands, there have been more than 300 million detections of nanotags. So the amount of data that is resulting from this technology is overwhelming. In addition to the basic research, Motus can help us learn where migration stopover areas occur. We had one of our rusty blackbirds detected for 9 days by one particular station in Pennsylvania. So we know that there's a stopover area right in that vicinity somewhere. We can do what's called full life cycle monitoring, because if you're trying to do effective conservation on a declining species, you really need to understand what is going on at each phase of the life cycle. And we've had studies on the breeding grounds, but we didn't know where those birds were spending the winter. There have been studies on the wintering grounds, but they don't know where those birds are breeding. So now we can begin to link breeding areas with wintering areas, and also understand the timing of migration in both directions. There is also wonderful opportunities for citizen science and education outreach. And I mean, at some point, you folks might think about getting a mobile receiver and a couple of transmitters just to use with kids, so that they could, or even college students, so that they can get the experience of using the technology directly. I think, yes, stay tuned. You're the first, but there are 49 more to follow in New England. And hopefully next year we will be able to get out in the field a bit more than we were able to this spring and get more tags on.
The first question is kind of related to what you were just saying about the educational potential. And so with this one that's kind of transmitting to a cell phone tower, so how soon does that detection appear on the website, and can anyone go and just look up the Stoddard, tower and see which bird, what kinds of birds have passed by? Or
yes,
how will it
I
work?
believe, actually that's an interesting question. I mean, the only way I have done it is to get the SD card and plug it into the computer and upload the data that way. And when you do that, the data is usually on the website within a couple of days, unless, everybody's coming back from the Arctic Circle and uploading their data simultaneously and they're swamped or something. To what extent they have gotten this automated on their end now with this automation on the receiving station, and I really am not sure, but it would certainly be much more quickly than waiting for someone to go out and switch out SD cards.
Right. And once they've got it, can anybody go onto the Motus website and click on that dot and see the species that have been detected there?
Yes, there are different levels of information. So there's certain information that the public can see. There's other information that as a researcher I can access, but you couldn't. But that's kind of getting down into the weeds of the actual, you know, what time and on which antennas and that sort of thing. It's a huge amount of data that is kind of challenging to. It took me quite a while to figure out what it meant. But in terms of just clicking on a particular station and seeing what it has detected, anybody can do that. And one thing, stations that are deactivated and then reactivated, there's a little time thing up at the top. So like right now, our station just shows the 3 detections that have been made in 2020 since we got it up and running again. But if you went to an earlier date on that time thing up at the top, you could see the data from last year.
And then you could click on one of those detections. You could click on a detection and then see all the other places where that individual animal was also detected.
That's a little more complicated because I think you have to, it'll say what project that bird is part of, and then you have to go to that project and that bird, and then it's a little more complicated, but it's doable.
We're really excited about the potential of including this in some of our education and teaching programs, and so we're hoping, you know, especially our birds, you know, our station. So I'm sure we'll familiarize ourselves with it once it gets up and running and how to share that,
Yeah.
not just in school programs, but in the public too.
There's a whole educational curriculum that's being developed by some folks in Pennsylvania. And it's still in development, but there will be some units from that will become available as well.
Great. So one question I hear a lot, and we got this tonight too, is a question about the tagging and carrying the tags and whether that presents any discomfort or danger to the birds. And if have there been studies on this?
There have been, and there are, the bird banding lab has, I mean, they're stronger than guidelines, but you can only put hardware on a bird that adds up to such and such a % of the bird's total weight. So you have to size the transmitter to the bird, to the individual bird. So when we're capturing rusty blackbirds, for example, and we know that these transmitters weigh, they're probably a gram or 1 point something of a gram, then when she captures the bird and bands it and weighs it, she knows whether or not she can put a transmitter on that bird based on its weight.
Great, Thank you.
Needless to say, the one you put on a red knot is going to weigh a lot more than one you put on a rusty blackbird.
And the
Or a
advantage of
hummingbird.
the ones that weigh more is that they can last
longer.
Yeah. Do you know of any other locations of receiving stations to come in southern New Hampshire? There was questions about like where will our nearest one be other than Langdon, and do we know that yet?
We don't know that yet. We have sites both east and west of you that we're looking at and doing the GIS analysis on. We have not yet reached out to landowners to investigate whether or not they will be willing to host a station. I mean, because, well, Phillips Exeter is also an early adopter, so their station is hopefully going to go up in early December. We have to wait until they're sending all the students home for Thanksgiving, and then they will finish the semester at home. So we have to wait until the students are gone before we can. That one's going to be on the roof of the library. So in the near term, that will be the nearest one on your actual line. But I mean, the shorebirds, we're mostly getting shorebirds right now that are either getting tagged in the Arctic or getting tagged in South America. So they've pretty much already gone south. So I don't think there will be much happening this winter, but you never know. So because we've kind of got one on each end of that line is going to get high priority this winter for figuring out where the other ones are going to go so that we can get the rest of that line up kind of first thing next spring. So you'll know by next spring, but it's going to take us a while to get all that figured out.
So there's one last question I'll ask before we wrap up. So Karen, there were two questions that are related. One was, will the Harris Center ourselves be doing any tagging? And the answer to that is not now. We don't have any plans to do that. We don't really have the capacity to do that in-house yet. I'd say that we aspire to do that in the long term, but in the short term, the Harris Center is just hosting the receiving station. We're not doing any tagging. And then Kim said, partner with Antioch for tagging. I have talked with some Antioch faculty about that, but maybe we should revisit that discussion because it's been a little while. And then will New Hampshire Audubon do any tagging? And that's the butterfly project, right? That you were
Butterfly project, and then we will also be continuing with the Rusty Blackbird project, hopefully for the next 3 years anyway.
Wonderful. Well, I don't want to keep us here too long, but I just want to thank you, Carol, for your time, not just tonight, but in shepherding this whole project forward. It's a really exciting initiative, and we're honored and pretty stoked to be a part of it. So thanks to you.
We're very excited to have you too. So.
And thanks to everyone else for joining us tonight, and to our 50th fund donors for making this happen for us here at the Harris Center. So many thanks to all of you, and maybe we'll see you for spiders on Thursday.
Yeah, I want to come to the spider thing. Great.
Wonderful.
Take care, everybody. Stay safe.
Bye. Thank you, Carol, again.